Hi everyone, I am Devi Salakshi from CSC Department, Rohini College of Engineering and Technology. Subject name is CS 3452, Theory of Computation, Unit 5, Undecidability. The topic name is Recursive Enumerable Languages. So today we are going to discuss about recursively enumerable language. The main objective of that thing is to understand the properties of recursively enumerable languages. Recursively enumerable languages. Recursively enumerable languages are generated by typogrammers. It means Turing machine can loop forever for the strings which are not a part of the language. A language is recursively enumerable if there exists a Turing machine that accepts every string belonging to the language. And if the string does not belong to that language, then it can be cause a Turing machine to enter in an infinite loop. Recursively enumerable language. This diagram shows the relationship between the languages. If a language recursive, then it is called decidable languages. If the language is not recursive, then such a language is known as the undecidable languages. Hence, broadly, there are three categories of the languages. Recursive language for which the algorithm exists. Recursively enumerable languages for which is not sure that on which input the Turing machine will never halt. Such languages are not recursive. The non-recursively enumerable languages for which there is no Turing machine at all. The important fact about recursive and non-recursive enumerable languages can be seen with the help of some theorems. So first we can see about the closure properties of recursive languages. Union, if L1 and if L2, two recursive languages, their union L1 union L2 will also be recursive, because if Turing machine halts for L1 and halts for L2, it will also halt for L1 union L2. Concatenation, if L1 and if L2 are two recursive languages, their concatenation L1 dot L2 will also be recursive. For example, L1 is equal to A power n, B power n, C power n, that is n is greater than or equal to 0, as well as L2 is equal to D power m, E power m, F power m is greater than or equal to 0. Automatically L3 is equal to L1 concatenation L2. So it's also a recursive part. Recursive enumerable languages, the clean closure property we can see. If L1 is recursive, its clean closure L1 power star will also be recursive. For example, L1 is equal to A power n, B power n, C power n, that is n is greater than or equal to 0. L1 star is equal to A power n, B power n, C power n, n is greater than or equal to 0. It's also a recursive. Intersection complement. If L1 and if L2 are two recursive languages, their intersection L1 intersection L2 will also be recursive. For example, L1 is equal to A power n, B power n, C power n, dm, n is greater than or equal to 0 and m is greater than or equal to 0. L2 is equal to A power n, B power n, C power n, D power n, n is greater than or equal to 0 as well as m is greater than or equal to 0. L3 is equal to L1 intersection L2. A power n, B power n, C power n, D power n, L is greater than or equal to will also be a recursive. Thank you.